Welcome to Neural Nebulae, where we will unravel the mysteries around artificial intelligence, clear out misconceptions, and explore its transformative impact on industries, its various use cases, and important considerations that you need to make as you embark on your AI journey. Here in our second episode, we're going to unwrap AI and generative AI. We will distinguish various AI categories, their capabilities and approaches, ranging from natural language processing to generative AI. We'll also delve into use cases for each category and essential factors to consider when adopting AI. My name is Kenneth Henricks, Senior Customer Solutions Architect at Calent, and joining me today is Brian Tarbox, Principal Solution Architect, an Amazon Community Hero, and an Alexa Champion. Let's dive right in.
Hey there, Kenneth. Well, everyone's talking about Gen AI, and I think we need to set the stage for, where is Gen AI on the whole AI, ML, generative, where is Gen AI on that spectrum? Because I think there's a lot of confusion. This is taking the whole world by storm, it seems, and so setting some baselines might be a good start.
Yeah, absolutely. It's a common misconception that we hear too. There's a lot of people that think that generative AI is the next evolution of artificial intelligence, and in reality, it's another stream of artificial intelligence. It's another category or grouping of it. Traditionally, we like to call AI that's been around forever analytical AI. These are things that are doing your traditional machine learning processes are sitting behind it. You're doing forecasting, et cetera. These are tried and proven processes. We have what we call today narrow AI. They've got narrow or weak, general, and strong or super intelligent. And if we double click into those just real briefly, your narrow or weak AI is what we have today. It's AI that is trained to be really good at one particular task, but it's not good at a broad range of tasks. And you would typically have to chain together multiple AI processes in order to be more well-rounded or more of a generalist. That general and strong AI is not something that we have today, but it gets closer to emulating what an actual human might do, because as humans, we're typically skilled at doing many things. Maybe we're highly skilled at some things and we have average skills in other things, but we're not such that we can only do one and only one thing. And this is where general AI will take us, is an AI that has the ability to do more than one thing and do it really well. There's a lot that believe that this is not possible, but there's also those that believe that this is possible and we will get there. Obviously, time will tell. Super intelligent AI is that which has the ability to surpass humans. And so this will be able to perform complex tasks that even humans can't do today. Like, for example, solving worldwide problems or global problems, being able to think globally beyond the scope of just one human or one group of humans.
Right. Well, and this makes me think of what we used to call expert systems back in the day.
Yes.
And an expert system was expert at a particular thing, but it didn't have generalized knowledge. And I remember there was also the notion of assistance. And I'm a pilot, not a fighter pilot, just a regular pilot, but there was the notion of the fighter pilot assistant that would, gently whisper into the pilot's ear, we're running out of fuel, you might want to head home. But it would also know not to mention any problem with the landing gear during a dogfight, because you might not make it home, might not be an issue. So it would have some intelligence, but very limited. And the thing is, the scoping really makes things easier. I mean, I do a lot of work with, and I'll say Alexa quietly because I forgot to turn her off, but and maybe I'll do that in just a sec. But those systems are designed to really narrow the scope of what it's responding to give it a hand, because, as you say, the general knowledge is tough. And I'm not sure right now I would want ChatGPT to be saying how to solve world hunger, for example.
Although I'm sure it would give you opinions if you were to ask. I agree. I don't think that I would want that onus to be there. Yeah, that's a great example. I think that also illustrates that artificial intelligence has really been around an awful long time. The real value has been added through machine learning, because artificial intelligence at the end of the day is a series of pre-programmed if-then statements, right? If landing gear is broken and pilot is in aircraft, do not warn pilot because pilot may freak out, right? These are if-then statements that say in these conditions do this. And machine learning really brought in value in being able to look at historical data and automatically generate that logic, or those if-then statements, if you will. And that's the power that ML has brought into the scene. Whereas generative AI is a completely different area that doesn't really have so much to do with past historical data. It has more to do with creating new content that's not even here yet. And it's really the combination of those two things that I think provides tremendous value today. Not that Gen AI is going to replace analytical AI by any stretch.
Right. I think there's room for all of these things. I will say, back in the late 80s, I did some, my master's degree was actually doing some work with genetic algorithms, where it would, try to learn. It was very, very early days, but it would try to learn. And back then we used to say that, what's AI? Well, AI is whatever a computer can't do yet. We will just keep pushing the goalpost out. But I think right now there's a lot of people who say, oh, chat, it solved it. It's done. It's all good. It's like, yeah, not so much. And it's funny, going back to the world hunger, chat might come up with a solution to world hunger. We might not like the answer. It might be, hey, if you kill off half the people, it'll all be great, a la Thanos, So we want some guardrails too.
Yeah, absolutely. There's the ethical layer that I don't even think we agree universally what is and isn't ethical. I think we have a lot of overlapping ideas, but I don't think there's a universal definition necessarily. And if there's not a universal definition, you could never expect a computer to know or adhere to that.
Right, right. So an area that might be interesting to just to play with a little bit is how we train these systems, because if we compare some of the things like AWS Rekognition, for example, that will let you look at visual images and pick things out. We train that on lots of data. If you wanted to pick out fire hydrants, you show it 10 million pictures that are and are not fire hydrants. And there are similarities to what Gen AI does, but there are also differences. And I think that's worth chatting about.
Mm-hmm. Yep, absolutely. When it comes to a lot of these training algorithms, it's not as simple as sitting down and saying, here are all the different cases and here's what I expect you to do in these cases. But a lot of times it's going and plowing through historical data and looking at different situations that have been there in the past. And if you already have an example of what has occurred and what the expected outcome is, then you can use that to train a model, because you can say, here are the inputs that you're going to receive. And based off of what we've already done, these are the expected outputs, and I expect you to learn from that. And so, in the example of the fire hydrant, here's a bunch of pictures of fire hydrants, and I'm going to tell you already that these are fire hydrants, so that when I give you pictures and I don't know if there's a fire hydrant in the picture, you have the ability to tell me whether or not there is one in there. And so this reinforcement learning, where a human is telling a computer what's right and what's wrong and providing the feedback, so that the computer can start to dynamically build out the intelligence that it needs underneath the hood there to perform those actions when there's not a human present. A lot of this comes in the form of deep learning, which is a real fancy term that a lot of us have heard about recently, and these neural networks. And essentially what's happening here is this neural network is something that emulates the human brain and how the human brain processes thoughts and ideas and how it processes responses. And the neural networks are hosting a lot of these large AI algorithms and executing them. And so it's a way of breaking out and using the different computational power available to perform these complex functions. Your deep learning is what's used to really dig into the data to try to figure out what is the right way to look at future information and create the right answer based off of the prompt or the input that's coming in the future.
Right, right. And this gets us into some interesting gray areas. I hadn't seen it before this, but someone showed me the blueberry muffin versus Chihuahua picture. And I was like, what the heck is that? And then they showed me a picture, and it's like, if you take a picture of Chihuahuas from a certain perspective, I guess they do look like blueberry muffins. So there's lots of edge cases there. And then there's hot dog, not hot dog. So it's the training is really important. And one of the things that feels, at least to me, that's missing a little bit is the confidence factor. If you ask me, is this a picture of a fire hydrant? Fire hydrant, that's pretty black and white. I'll tell you yes or no. Is this a picture of a dog? It's like, well, I think so. And it seems like a lot of the current systems don't incorporate very, very well, or at all, I think it's A, but it might be B.
Yeah, absolutely. And that Chihuahua versus Blueberry Muffin is it's an interesting phenomenon, isn't it? I've looked at those pictures sometimes to where I can't even tell the difference. But I think it underscores the reality here that in artificial intelligence, we are not taking a human being and teaching that human being how to think and how to reason and how to rationalize. What we're doing is we're writing a computer program that emulates human behavior and human thought, but it is not actually a human and it's not actually thinking like a human. And so when you look at two pictures that are similar, like a blueberry muffin and a chihuahua, it's very easy for a human to look at those things and distinguish this is a dog and this is a muffin. And the reason is because we can understand what eyes are, we understand what noses are. Our brains are trained to be able to distinguish those sorts of features about things so that we can recognize those. And that's not something that we are able to actually emulate inside of a computer. So instead, what a computer is doing is it's looking more for certain types of patterns. And these patterns are similar, but not quite the same as what humans are doing. And this is where it's really important that any of these algorithms, no matter what they're doing, if they're trying to determine that it's an EV car that's automated and it sees somebody running across the street and it knows to stop, like that's a decision that's made based off of vision. You've got the simple example of, is this a hot dog or not? From our favorite Silicon Valley show. And then you've got this whole blueberry muffin versus chihuahua kind of thing, right? And in all of these cases, somebody had to tell the computer what the right answer was and what the wrong answer was. And if you pull back too soon and rely on the computer to get these things right, then you're taking a chance that it's going to be incorrect. And it's very important that there's a good quality of data training the system so the system is smart enough to understand the differences, but also that there's a level of human intervention that is there to monitor things to make sure that the quality stays where you expect it to be. Obviously, it's a lot more important in the case of EVs and stopping a car when someone runs in front of it than it is in distinguishing between a dog and a muffin, but the implications are still the same.
Right. And the EV example is really interesting because not to pick on our favorite EV manufacturer, so I won't say their name, but the detection of there's a person in front of me, I should stop, originally detected white males between over 5 foot tall, and anyone who wasn't that didn't count as a person, and so the car would not stop. And then there were some situations people said, "Oh, there are people who aren't men. Maybe we shouldn't run them over either." And it's like, hey, there are children. Hey, there are dogs. Hey, there are bicycles. And you can imagine at the beginning someone forgetting to say, hey, maybe we shouldn't run over bicycles either. So it's a crucial area, and you don't know what you don't. I mean, I'm sure there are things that that I wouldn't think of what not to run over. It's kind of, I mean, it's funny for a human. It's like if I see anything in front of my car, I stop, and it's that if I see a shape running across the street, I'm not going to puzzle over, oh, does this meet my criterion of things I should stop for? It's like, yes, it's in front of me, I should stop. It's that, and it's that common sense that is missing. And I think one of the things with ChatGPT is that, or the Gen AI in particular, is that it has moved so quickly that people are assuming that the common sense is there when it just isn't.
Yes, and that's the separation of the computer thought process versus a human's thought process. That's the example that you just gave of the car only detecting certain genders, certain heights, etc. That's a really good example of a bias to where likely that occurred because the training data didn't include a representative set of what was going to be seen. And so you've trained it to do one thing and trained it to do it really well, not realizing that the outcome was going to be biased and unfair as a result of how you trained it. And that's where having a robust production-like data set to train from is extremely important. This is an area that's really fascinating to me. I think we've only barely scratched the surface here, and I'm really excited to see how this unravels, is that the notion of using generative AI to create training and testing data. And so if we keep tapping into the EV example here, this is an unprecedented time and market with these electric vehicles, and not because they have, they're not using fossil fuels to propel themselves, but because they have so much intelligence built into them. That's really the advancement that I'm excited about. And when you think about the cases of how many different things do I need to tell this to stop for, don't stop for a cardboard box, but stop for a dog, stop for a ball, stop for a human, all these different things you think about, that means somebody has to think of the cases and somebody has to create those test cases to then test the system to see what it's going to do. And obviously we don't want to test this theory by driving a car down the street and having a dog run in front of us, right? That doesn't seem very scalable. And so what we're seeing is a lot of people wanting to test these kinds of things using like a digital twin inside of a metaverse with a lowercase m, not an uppercase m. And so if you want to start testing these cases, now you have the ability to expedite and to accelerate your testing, because you can generate a lot of this data to represent different situations that maybe you couldn't even think of, or combinations of scenarios that you couldn't possibly think of or code for. And then you can use that to feed it through the system and process it rapidly instead of in real time, and see what the outcomes and the decisions are of the car. And this can help you get to much more of a semblance of quality a lot faster than it would by simply waiting for, well, now we want to stop running over men. Let's go ahead and program it to not run over women also, right? And now we've run over too many bicycles. Let's add bicycles to the list of things, right? It can help expedite that particular process to help get you in front of exactly what you said, which is we don't know what we don't know.
Right. And the trick in I think in what you suggested is, okay, I'm going to use Gen AI to come up with training data to test the Gen AI or the EV, but I have to be careful in what I say. It may just be squishing the bubble or squishing the balloon, in that, I can have bias in my instruction to the system on how not to create bias. One of the things I'm actually just now thinking, I'm actually surprised that if I was running this system, I would get people to download dash cams for me. I'd say, hey, everybody who has a dash cam or a phone, go drive around for a week and send me all the videos, because that will be real world, cases. Because it's like, hey, hey, there's water on the road. How do I decide whether the water is too deep to go across? And then, of course, you have the systems there. It's driving along commonly for you, and then it says, I'm not sure what to do. I'm out. Hope you have your hands on the wheel, buddy.
Yes. Yes.
My own car does lane following. I don't have a high-end car, but it does lane following until you get a little slower, and then it turns off lane following, but it doesn't tell you they just turned off lane following. It's like, excuse me, I guess I better steer. So all really, really interesting things. And I wonder if we can learn anything from some of the other domains, like, natural language processing, again, mentioning, Alexa, Lex, Polly, there's vision, robotic process automation. There's all these other domains that have similar issues.
Yeah, absolutely. I think natural language processing is one that's really relevant today because of ChatGPT. A lot of people that previously weren't privy to using AI directly, such as people that are in the business realm and not necessarily in the technology realm, you no longer have to go run an API or deploy your own model to use artificial intelligence. You have the ability to put your hands on it really easily. It became a very tangible thing overnight. And the perceived value is in the ability of this to understand natural language and to spit back out natural language. Now, if you get underneath the hood and take a look, it's not actually understanding languages. It's not actually responding with understood language. It's using algorithms to figure out what's the right way to form words to respond to the association of the words that you gave me. But there's still a lot of power in this awareness of context and being able to understand the entire scope of what you've said or what you've asked, the prompt that you've given this bot. And when it comes to natural language processing, it's more than just simply taking one word and defining it, but it's looking at an entire sentence, for example, and understanding what the word means within the context. There's several different examples of where sentence can mean one thing or another depending on the context of where the sentence is, and I think that's what's very important here. There's some really exciting things with NLP, natural language processing, like translation, for example, is a really exciting one because, again, you're not just translating one word for another, but you're translating ideas into ideas. And I think we're seeing a lot more higher quality translations as a result of that sort of thing coming about.
Right. But that's a really hard area. I will say I have a soccer skill on one of these voice devices, and suddenly I was getting questions about hurricanes. And I was like, why are people asking my soccer skill about hurricanes? And it turns out, after talking to a British friend, they were asking about the British player Harry Kane, but hurricane. And it took even me ages to figure out, what was going on. And then in translation, there's also idiomatic things. In soccer, if a goalie doesn't let any goals, in America, we call that a clean sheet. And the first time I tried translating that into my Spanish version of the skill, it said, which goalies do the best laundry? And it's like, nope, nope, nope. That's not what I was doing. And it turns out there actually isn't a great idiom. So there's just nuances upon nuances.
Yeah. One of the other things that you just mentioned too is computer vision, which is pretty awesome also. This is looking at images or videos and then making an assumption or an interpretation of that. It goes back to the blueberry muffin, chihuahua, hot dog, not hot dog. This is the ability to look at images now and not just words or whatever. I think it's a really powerful space that we're going through here. And I remember talking with a customer not too long ago that was trying to revolutionize how some construction was done, specifically with a big digger. They were working with these big machines on doing construction out in the middle of nowhere. And the way they started was by hanging cameras and LiDAR systems all around these diggers, and then keeping track of how they're performing and how they're working. And one of the things that they wanted to focus on was looking at that bucket every time it made a scoop, measuring how much energy did it take to make that scoop and how much dirt did I actually get, and then how far did I move that dirt, so they could find out how efficient each scoop was. They were going to use it to start training their operators to becoming more efficient and effective with using these, so that they could dig these big trenches in a lot less time than they had traditionally taken to dig these trenches. And the overall idea, while that sounds like a great value proposition, the real idea was to be gathering information and data, like your dash cam example earlier, getting real world examples with real video footage of this happening in the real world and in real time, so that they could prepare an AI model so that somebody could sit inside of that and let the thing drive itself. And they're just sitting there watching so that they can override. And then the next phase was, once they had confidence in this thing being able to do all these things with these optics and vision equipment and LiDAR devices and all this, that they could then control it from some remote location, and they wouldn't even have to have somebody on site. They could deploy all of these construction assets, and they could set up shop in some office somewhere else, and they could start remote controlling to get things in place, and then turn over a program and let it go dig a trench, 100 miles long or whatever the need is for that particular case.
Right. That's a scenario where I would want some assurances that there is quite a lot of training, because having an excavator, hey, excavator, go crazy, man. That's interesting. I mean, it's funny. One of my friends actually was working on autonomous tractors for harvesting, and that turns out to be, you think, well, it's big flat field. What can go wrong? Well, all kinds of things can go wrong. But also collecting that data might also be useful for training human operators in safer situations. It's probably, I assume an excavator is pretty expensive. Training an operator, via VR headset or something is probably a lot cheaper than putting them out to a field and having them dig like crazy.
Yeah, absolutely. And you mentioned safety, and that's another important aspect too, because, with computer vision and construction, you have the ability to look and see who's wearing safety vests, who's wearing safety helmets, et cetera, and then call out situations where people are following the rules and situations where they're not, in order to measure current levels of safety and increase levels of safety.
Right. It's a great space for us to help the world. I mean, I know some people are like, "Oh no, the killer robots are coming." It's like, well, yeah, maybe, but it also may be that we're making life a little safer for people. And then there's sentiment analysis is a really big thing that's present in a lot of systems. Not surprisingly, not present in a lot of systems. And I think that's an area where there's quite a bit of room for improvement.
Yeah, absolutely. And sentiment analysis a lot of times is related to the terminology and verbiage. And, for people like me that have a dry sense of humor, sometimes it doesn't translate the right sentiment. And then, there's not enough of, but I'm hearing a lot more cases of wanting to use tone and voice and inflection voice, and then also having a vision aspect to be able to look at body language and to look at facial expressions and things like that, and sort of combine all of those things together to get a much more accurate representation of what the real sentiment was, not just simply based off of the vocabulary that was spoken.
Right. Well, it's funny. I worked at a company that did real-time sentiment analysis for call centers, and one of the real milestone achievements was being able to distinguish the case of the agent and the customer are laughing together versus the customer is laughing at some suggestion that the agent made. And we used to joke that lots of humans don't get that difference. But it's really tricky. And it's funny. A lot of sentiment analysis isn't the words. It's, as you said, it's the body language. It's the energy vector of the waveform.
I wanted to touch back also on you'd mentioned the robotics and things like that. Robotic process automation. There was another use case. I'd worked with a guy as a colleague of mine, and he worked for a payment processing company that put the little small screens on tables in restaurants where you could pay your bill or you could order more food or whatever it was right there at the restaurant. And they were working on doing QA of the actual screen and the interface, and they were having trouble with sometimes how the software worked and functioned on the actual touch screen itself. And so it wasn't just simply testing the software and the APIs and the interface and all that, but it was testing the intersection of the software with the actual hardware. And so they designed these little robotic devices that had a rubber hand on top of it. And they used like an Arduino board to program it to where it had the ability to look at the screen and they could tell it to go push these numbers for putting in a PIN for your debit card, or to push these numbers to pay and these numbers to do a tip. And so now they're testing the intersection of the hardware with the software as a result of these robotics. And it was a pretty low budget type investment that they made, and it had tremendous value in getting higher quality products out the door. And it's just such a cool case.
Wow, that's clever. So we have all these sort of existing cases, vision, NLP, robotics, and so on. And now along comes generative, as I say, and the crowd goes wild. So, how do we make that? How do we absorb that? How do we help our customers and our clients absorb that transition? Because it is a transition, and there's lots of, as with most things, there's lots of nuance.
Yeah, absolutely. It's incredible. I've been in technology for a really long time, and I've never seen anything create quite the buzz that Gen AI does. It has literally been the topic of every conversation that I have had. It's the topic at public presentations. It's what's hot online. It's all over my LinkedIn feed. It's in every single call that I have with customers. They may not be wanting to solve for Gen AI, but everybody's talking about it. And I think we're just barely scratching the surface here. I think there's a lot of value that we're going to get to, but I don't think we're there yet, because I don't think the quality is quite there. You've got things like hallucinations that come out, et cetera, and you can't really rely on the quality of it. Like if you were to program a system to use Gen AI to generate an email message to your customers and you didn't review it, you're probably asking for trouble. I think it's going to blow up in your face, because we're just not quite there with it. But there's some exciting things that can be done through generative AI. They've got some things they call modalities, and so which is basically what kind of stuff is it going to spit out when you give it a prompt. And you've got your standard text, and this is what everybody can already put their hands on. This is ChatGPT. Things like write me a poem that has to do with me riding my bicycle to check the mail on a nice 105-degree day in Texas. And you get back this really cool poem, and every other line rhymes or whatever, right? So you've got the ability to do that. We're seeing applications in text summarization. So things like legal cases, so recording depositions, and then at the end of this deposition being able to create a summary so that an attorney doesn't have to go watch 2.5 hours of deposition footage. Instead, they can go back and ask for a summary of it, and then ask questions like, what did the defendant say here, or what did the plaintiff say here, to ask questions about it instead of seeking for the answer. We're starting to see a lot of power in that. This also applies to things like knowledge bases. So people have knowledge bases. You can load these up in and then start interacting with it through NLP type prompts, your natural language processing. Images and video are really cool. Describing something that you want to be created and having an image spit out. We talked to a customer, worked with them, where they created this model to turn a phrase into a 3D asset that you could then upload into the store into a game called Roblox, which I don't play and don't understand, even though I am a gamer, but my children play religiously. And the idea is that you say something like, I want a unicorn, going down a golden brick road with a case of Mountain Dew in the back, and then it generates this 3D asset, and then you put it in the game and you go sell it in the game. And so, it's the ability to turn text now into assets. And I think we're going to see creativity explode, because I think there's a lot of creativity in minds that doesn't translate to drawing necessarily. And I'm absolutely one of those guys. I can't draw a straight line with a ruler. but I can think about some interesting things sometimes, and being able to visualize those, I think is going to be amazing. The idea of doing research is incredible. Instead of asking Google for something and then finding an article and scanning the article and finding your answer, what you're researching, we have the ability now to synthesize that information and get summarized information back, similar to the deposition case that I gave earlier. And so when you're doing research on a topic, rather than, again, asking Google for, where is this at, and getting a web page and reading through it and synthesizing it, you can get that pre-synthesized answer back. And then also probably the most exciting in generative AI is what's touched on earlier, which is the creation of synthetic data. That's an area where I think that we're going to see explosive value coming.
Right. Especially because that helps us eliminate the whole issue of PII. You want to,
yes,
lots of systems, so many systems now are healthcare or personal identifiable information of one set or another. You want to be having your test systems data look like real data, but then you have to, de-identify it, and that's a whole process. And if you can, synthesize the data, I think you're exactly right. A trick of all this is, to what degree can you trust the answer? So there's the story going around that there are some people who've written some ChatGPT driven books on finding mushrooms.
Oh yes,
and people are. But it's not really distinguishing the mushrooms you can eat from the ones you can't. And I don't know if anyone has legitimately perished because of that, but that's what I'd call a downside.
Yes. Yeah, that's absolutely something to watch out for. That's where it's super important for there to be a human in the loop to govern the quality of it and not just blindly trust what's coming out. But I think on the flip side of that too, us as consumers are going to need to be a little bit more aware about content that we are processing to better understand what is the source of this content. And if it does come from a machine, is this something that has been vetted for quality? Or am I possibly consuming misinformation that looks really legitimate?
Well, that's a question that we won't go there, but what is truth? What is truth these days? That's another whole podcast. We'll leave that to the late night comedians to chat about this. Dare we say that Gen AI is truthy? I don't know. But a place that I have already found real value is in the coding assistance. So I was one of the early folks using Code Whisperer, and there's also CodePilot, of course. And Code Whisperer has blown me away a few times with some of the levels of understanding that I simply did not expect.
Yeah.
So I was playing around with a Python inventory class just because Code Whisperer is trained, on Amazon APIs, so it's really, really good at generating things for Amazon APIs. And we're like, well, let's just take a random Python class and see what it can do. And I had this inventory class, and I said, hey, make me a function that finds all the items that are more than $10. And the function it created was named items that are expensive. It's like,
oh, clever.
Whoa, move me away. And then I said, okay, items that are less than $10. And it said items that are cheap. And it's like, okay, I did not expect it to understand at that level.
It's more scalable code too, because now the definition of your metric of what is and isn't expensive as being $10 no longer matters to the naming of your function.
Right. And then, there was another time where I'd written some Python variables, and then I wanted to log them out, and I typed LO, and it said, oh, do you want a log statement with the Python F string showing you the values of the 3 variables you just set? And I'm like, yes, I do. Thank you. And it saved me 20 seconds, and I'll take 20 seconds, but again, it felt like I had a buddy there with me. Now, of course, it wasn't a buddy there with me, and there's no actual intelligence, but it certainly met a lot of the definitions of intelligence.
Yeah, I'm hearing really exciting stories in that vein too. We were at a generative AI CXO roundtable recently, and one of the people there said that he is able now to code at a rate of 4 times faster as a result of having these code agents, things like Code Whisperer and CodePilot. That's an incredible metric. I mean, being able to say I'm 10% faster or 15% faster, that's already a great story. But saying that you're able to produce code 4 times as fast, I mean, think about how quickly we can get through technical debt, and how much we can slow down the accumulation of technical debt if we can actually produce things at that rate. It's incredible.
Right. And I think I have found that it also changes how my perspective on what I learn, and what I keep in my primary cortex as opposed to my exocortex, in that there's lots of AWS function calls that I make that like create a CloudWatch metric. I've written that code 100 times. It's 40 lines of JSON. And every time that I've written it, I've had to go jump out of my editor, go to the documentation, figure what are these stupid 40 lines? I shouldn't know that. I don't want to remember that. I don't want to know how to write that. It's like, chat, give me a CloudWatch metric, and it does it. And I'm done, and I don't have to think about it. And I never had to leave my editor, so I stay in flow.
Yes. Yeah,
So
no context switching.
right. It's do this for me. Because I read just even the other day, I mean, I think we all know about the cost of context switching, but it was an article on don't tap engineers on the shoulder. They said, if you tap an engineer on the shoulder, you've burned 23 minutes, which I believe.
Me too.
Yeah. So, and this is an interesting area where, again, it's domain limited. So I'm not going to ask CodeWhisperer, is this a blueberry muffin? I'm not going to ask it like that.
Yeah.
But I suppose I might, say, hey, call recognition and do something interesting. But the domain limiting really helps. And I have to give a shout out to Amazon for a couple of things they're doing in CodeWhisperer, such as the attribution. There's all kinds of open source. There's licenses about open source. If you're using open source, and CodeWhisperer and Copilot are trained on open source, there are times when it's very, very important to do attribution, and CodeWhisperer is designed and has been designed from the start to help with that. So keeping us legal is also a darn good thing. And I just like that they've thought about that. The fact that they thought about that makes me think, okay, they're thinking about some of the right things.
Yep, absolutely.
And they also, in just jumping back to the training data, I think it was last year at reInvent. I don't know. These last 3 years are such a blur. It could have been last week. It could have been 2 years ago. But they have a tool that will specifically look for bias in your training data.
Yes.
So it's good that they're, it's good that they're doing that. I'm sure it could be better, and I'm sure it will be better. But it's a step in the right direction.
Yep, absolutely.
So one of the things that strikes me is that so much of this that we've talked about depends on the data. And while it's not necessarily the coolest part of the whole system, cleaning up your data is important, and having cleaner data will help no matter what you do. So if I were to recommend a strategy to people, it's think about what you want to do with these new AI tools. And while you're thinking about that, have your folks go clean your data, because that will take some time, but you'll be glad that you did it as you're thinking about what you want to do with this data. And then you can figure out what the use cases might be.
Yeah, absolutely. It's never been a bad time to get your data house in order, but it is absolutely a critical time to get your data house in order. I'm reminded of a time when I worked for a company where we had siloed departments at the company, and one department was really good at creating this data warehouse, and another department was really good at producing insights out of that data, but they were disconnected and they were not aligned on what was happening. And over the course of years, what happened is this data engineering team was producing this data warehouse and spending all this effort on it, and that wasn't actually being consumed. Instead, this team of data analysts was taking the data and they were doing more massaging, more transformation, more preparation, et cetera. And they weren't spending hardly any time analyzing the data and producing value out of the data. Instead, they were trying to undo all of the things that the data engineering team had done to get it back into its raw form. And the atrocity there really is, now you've got these people that were hired to be data scientists, they are hired to be data analysts, and they're not doing those roles. Instead, they're they're undoing and unraveling things that a data engineering team did so that they could just get a little bit of value. And if there had been more of an alignment and been more of a data-driven culture or data as a product type culture, I think that would have been completely different. They could have spent all their time and their effort working on good, clean data that's useful and relevant to them, instead of working through stuff that caused them more effort to be able to use it. And what we discovered, we went through some transformation and we were able to fix that. But what we discovered is that there is a cost to getting good, clean data. And it's not just good, clean data, but good, clean data in the format that it's usable to your downstream consumers. What we found is that you will pay that cost. And it is much cheaper to pay that cost upstream, where you're producing the data and first capturing it, than it is to let it trickle downstream, where you have these people that are supposed to be making decisions for your business, because they're going to fix the data and they're going to clean it. But when they do, it's a lot more costly to do that far downstream.
Right. Well, it's interesting. AI doesn't mean that you throw out all your good engineering and development practices. It's the old thing of, a bug is easier to fix in the design document than once it's hit production, and every time it goes one more, it's probably 10x the cost. The same for data. The same for AI. And one of the things we're also seeing is, given that things are in such a state of flux, we need to stay agile, which doesn't mean it's necessarily agile or Scrum agile, whatever. But you need to stay. We need to stay flexible, because the models that are current right now are not probably are not going to be the ones that we're all talking about in December. So it's as we move into this, keep the mindset that I have to be flexible and adaptable, but all my good engineering practices still need to occur. I still probably need to do blue, green, or canary deployments, because there's got to be issues. So it changes it. I guess we say it changes everything except for the things that it doesn't.
Yep. Yep. So you've got a really good point about software best practices with regards to testing and change automation, things like CI/CD and source control. This is why we have things like ML ops, ML operations. This is why we have things like DevOps. Another thing that I saw at that company too was, through this analytic department that was building all of this ETL, they weren't testing it, and they weren't putting their code in source control, and they weren't versioning their code. And of course they weren't trained classically in engineering principles. And so it's no wonder that they weren't, right? It's through no fault of their own. I mean, in reality, the real problem was they were forced to do something that they shouldn't have been forced to do to begin with. But regardless, the point that I want to make here is that the idea of versioning what you're doing and putting it in source control and testing, these are tried and proven practices that have been around in software engineering for decades. And so this is not brand new, the strategies to how do I test AI models? How do I test ML algorithms, right? This is not new concepts, but it is concepts that absolutely need to be there. We don't need to go back and relearn all of those painful lessons that we learned to get us to modern, robust, mature software engineering principles. We don't have to relearn all those lessons just to learn how to do them in the realm of AI and ML. Those are things that we can bring those lessons forward, and we have the ability to tap into those things so that we can make much more economical and effective use.
Right. And I think it's actually even more important, if I can do another metaphor. If I'm using a handsaw, I have various safety protocols I should use. If I go to a circular saw, I better be doing more safety, because it's faster, and the risk is higher. So as we move faster, and with implications of, don't run over the bicycles, the safety measures, the standards, the discipline, dare I say, the engineering becomes even more important.
Yeah.
So I think the companies that have strong engineering principles and practices will do well. So Kenneth, what advice would you give to a company that is dabbling with this, wants to figure out how to make use of these technologies, but isn't quite sure what to do next?
Yeah, for sure. So, I mean, we've touched on a couple of very important things, which are make sure that your data house is in order. You can't really do anything economically through AI if you've got a pile of data that's just completely trash quality. So things like that are absolutely important. And, thinking about the concepts of source control and CI/CD, just like we do for software, for doing it for AI and ML. But there are other things too. First of all, you should really be focused on your customer experience, don't get wrapped around the axle about the technology, right? It's a shiny thing and it's a valuable shiny thing, but that's the generative AI is not what's important to your customer. The experience is. And
Right.
my favorite example is thinking about Alexa and Siri, both in those digital assistants. Apple does not advertise Siri as this amazing artificial intelligent chatbot. It's a digital assistant, right? They don't need to tell you that there's AI behind it because that's not important to them. What's important is the concept of the digital assistant. And so
Right.
I think that value proposition is what really needs to be the first forethought and be the North Star. And once you've gotten there, then there's a lot of tactical and a lot of technical things you can do there. Some of this is uncharted territory, especially for companies that don't have data science departments, or maybe they don't have their data house in order. And I think these are really good opportunities to accelerate that by leaning in with a partner like Calent. We've got data teams that are skilled. We've got breadth and depth across data engineering practices. So we understand transactional data stores, we understand analytic data stores, et cetera, how to build AI models, how to test them, et cetera. Being able to use a partner or somebody that's got that history and that breadth and that depth can really accelerate the time to value for end customers when it comes to deploying these things. And then once you've got that head start, now you've got the first thing out there, you can start to incrementally improve and let the solution evolve over time as your value proposition changes.
Right. If you're going someplace you've never been before, might not be a terrible idea to get a guide.
Yep, 100%, absolutely.
Well, thanks. This has been really interesting. There's so much going on. There's so much churn. There's so much excitement. There's upside. There's downside. There's fear. We'll see where things go, in the next couple of months. But I look forward to us continuing these conversations and engaging our customers and seeing what they come up with.
Yeah, absolutely. Well, it was a pleasure to speak with you today, Brian. Thanks very much for the conversation. I found it entertaining and insightful. And, I agree. It's a very exciting time. I think we've only scratched the surface. I think that we're going to see some incredible value propositions created and amplified through the use of generative AI, but not generative AI alone, coupled in with things like traditional analytic AI and things that have been around forever. And my favorite cases are those where we're not touting the generative AI behind it, but the actual value and experience to the end customer, because I think that's ultimately what matters. Thanks again. I appreciate it very much. All right, that concludes our episode of Neura Nebulae. I hope that you leave with something to think about as you pursue innovation with AI. In our upcoming podcast episode, we'll explore a range of topics, including complementary capabilities of AI and its role as a tool, the creation of new job opportunities, and how you can optimize your skill sets for AI collaboration. If you've enjoyed the show, please leave us a rating and review on the platform that you're listening on, and don't forget to subscribe so that you never miss an episode. Thanks for listening, and we'll see you next time. Thank you.